Good morning, Altaloma. What's happening? All right, so today we're talking about something called completing the square. Completing the square has many uses. What we're going to use it for is to solve a quadratic function. We're still solving quadratic functions. You can do it by square roots, by graphing, by factoring. You know how to do this. We're finding the roots, the zeros, the x-intercepts. We're still finding the x-intercepts when we complete the square. Another use is to change forms from standard form to vertex form of a quadratic function. So that's what we're doing. That's why we're doing it. You'll be using this, as I've said many times, for years to come. All right, when we talk about completing the square, what we're talking about is completing a perfect square trinomial, and you'll remember those things, I'm pretty sure. But here's an example of a perfect square trinomial: x squared plus 10x plus, oh, wait a minute, what is that number? What would that number have to be in order to complete a perfect square trinomial? Well, it's pretty clear. I think if you remember this, the answer would be 25. Now, how did I get to that? Well, because I know that 5 squared is 25 and 2 times 5 is 10. So this is a perfect square trinomial. And when I put this number right there, then you know what I did is I completed the square. Here's another example of one that we can do. You guys know how to do this. Here, number 2, x squared minus 14x plus, what goes right there, people, to complete this perfect square? It should jump right out at you that, 14, that's 7 times 2. And that means this is going to be 7 squared. That's 49. Look what I did. I just completed the square. Here's another example. This is one where a is not 1, but this is a perfect square, so that's 2 squared. You might remember that this middle term needs to be 2 times the square root of that, which is 2, times the square root of whatever this is. We need a perfect square that makes this 20. Well, 2 times 2 is 4, and 4 times 5 is 20. And if this is 5 squared, then this must be 25. Boom, a perfect square trinomial. I just completed the square by finding that number. Now, we both know that it's never that easy, but you can do some of these in your head. When we start getting into solving, it's not going to be that easy. Here, watch. Check this out. Everybody together. Ready? On the count of 3, tell me what number you put right there. 1, 2, 3. What? What? I can't hear you. Speak up. Stop talking to your phone. You probably look strange. Well, this is 2 times 9. This is 9 squared, and that's 81. Boom. I just completed the square. Of course, that's not what it looks like when we start solving, but that's the idea. We're trying to make perfect squares. By the way, why do we make perfect squares? So that we can factor it. You remember this one gets factored this way, x plus 9 squared. This one right here is going to be completed this way, 2x plus 5 squared. Why do we want to complete the square? So that we can factor it into these easy things like that, all right? Now, let me show you how we're going to solve a quadratic by completing the square. All right, everybody, here's how I'm going to do this. We've done this plenty of times. By the way, I'm pausing in between videos, or in between erasing this thing to make these videos as short as I can. So feel free to pause it to catch up when you need to. So anyway, here's the problem we're going to do. We're going to solve this. X squared plus 12x minus 13 equals 0. Now, when you look at that, that looks like something we could probably factor and solve, and that's fine. You have to be mathematically agile, but in this case, we're going to use this one as an example to complete the square. So the very first thing you have to do, step 1, is if there's an a that's not 1, in this case it's 1, then you have to divide everything by it. So here I'll say, if a does not equal 1, divide each term by a. Now, it turns out in our case this is 1, so I don't have to divide every term by 1, but we'll do an example where you do have to, but for now I don't have to. So the next thing I have to do, step 2, is to get rid of c. Well, here's c, and I need to get rid of it, and what that means, of course, is I'm just going to add 13 to both sides like that. And this is going to leave me here x squared plus 12x. And then I'm going to leave me a little space right there, and I'm going to make that 13. Why am I leaving that space, everybody? You know what I have to do. I got to complete the square. You probably already know what number would be right there. What number would go right there? What? I can't hear you. Is that joke getting old yet? All right, please hold. All right, as I said, you probably already know how or what number goes there, but I'm going to show you what it is. It's 36, but the question is how do you get it? Because that's really important. How do you get that number? Well, here's what you do. You take half of b. Here's b. What's half of 12? Of course, it's 6. So you take half of b, square it. 6 squared equals 36. And add it to both sides. So I now need to add 36 here, but it also needs to go over there. By the way, that right there, this right here, is the most commonly made mistake. People forget to add it to both sides and messes everything up. And what we're going to do is we're going to rewrite that now. So I end up with this. I have, actually I'll use the red. Once I just simplify, you know, x squared plus 12x plus 36, and that now equals 49. And clearly this right here is now a perfect square trinomial, which is wonderful because what I need to do now is factor the left side, which should be really easy because it's always a perfect square trinomial. So since this is 6 times 6 and this is 2 times 6, then this must be x plus 6 squared equals 49. So this should be fairly simple because we've created a perfect square trinomial, which is really easy to factor. That right there, there's our shortcut, right? That's why we learn those shortcuts. Now it just becomes a square root equation. I just got to solve. Like I'm just going to take the square root of both sides like this. You know that will cancel that. That's going to make this really easy. And this will just be x plus 6. Of course, you know what the square root of 49 is. It's both plus and minus 7. So be careful there. So step 5 is just take the square root of both sides. Of both sides. And then step 6 is pretty simple. Just solve, right? So 6 is solve. Like this, right? And so now what I'll do is subtract 6 like so. And what do I get? I get this. X equals negative 6 plus or minus 7. You know that that is x equals negative 6 plus 7, which is 1. There's one of my answers. And x equals negative 6 minus 7, and that is negative 13. Here are my two answers right here and right here. I can write them here. X equals 1 and negative 13. These are the roots, the solutions, and the x-intercepts. Take a look at them. Okay, here's an example that's going to get a little bit ugly. And it's going to get a little ugly because this number is not 1. So let's go back through our steps. Step 1, if a does not equal 1, and it doesn't, then I have to divide everything by it. And you can see that's going to make a fraction. That's a bummer. So you watch. I'm going to divide by 2, divide by 2, divide by 2, divide by 2 over there. We all know that that's just going to be 0, but this is what kind of happens. This goes away. I get this x squared minus 5 over 2x plus 2, and that equals 0. And this is going to cause me a little bit of a problem, but you guys are honors kids. You guys got this. Step 2, what am I going to do? I'm going to subtract 2 on both sides. I got to get rid of c. That's what I'm doing. So step 1, divide everything by a. Step 2, get rid of c. I'm doing that right now. X squared minus 5 halves x. Leave myself a little space there so that I can complete the square. And maybe you're asking yourself, how can this be a perfect square trinomial? I'm going to show you. We're going to do step 3 right now. What's step 3? Well, I said take half of b. All right, what is half of negative 5 over 2? Well, you know how this works, right? Don't you just multiply straight across? So when I multiply straight across, I get negative 5/4. fourths, like this. This is extremely important number here, okay? And it's going to come into play in just a minute. But I'm supposed to take half of b, then I'm supposed to square it. Well, when I square this whole thing, I get 25 over 4, and that's what I put here, over 4, over 16, my bad, over 16, like that, 16. And over here, I add it here, 25 over 16. Don't forget, it does say add it to both sides. This is the most common mistake. People forget to do that. But now you're asking yourself, how do I do the next step? And the next step is factoring this left-hand side. Like, you know it's supposed to be something squared. I have a hint for you, and it's a trick. It's actually a really easy thing to do. Basically, you're asking what goes here. It is always this number right here. Whatever half of b is, that is what goes right here. Watch, it's really simple. This is just x minus 5 fourths squared. Always. Whatever the half is, goes there. So don't trip out on trying to figure that out. It's not that tough, okay? And then, of course, I've still got this negative 2 plus 25 over 16. I can do that over here and just make it negative 2 over like this, and this is plus 25 over 16. I got to make common denominators over 16, 25 over 16. This is negative 7 over 16. So here's what I have. X minus 5 fourths squared equals negative 7/16. So now what do I do? Well, I gotta take the square root of both sides. Look at this. You thought I only had one whiteboard, but I'm fancy. I'm so fancy, you already know. Anyway, here it is. Let's finish this up quickly. This is x minus 5 fourths squared equals negative 7 over 16. I'm going to take the square root of both sides. This, of course, cancels that. X minus 5 fourths, like this. What do you do here? You break it up. This is the square root of negative 7 over the square root of 16. What's the square root of negative 7? You know, plus or minus square root of, oh darn it, it is plus or minus I radical 7 over 4, like that. And now I need to add, I got to solve. So I'm going to add my 5 fourths on both sides. This goes away. X equals 5 fourths plus or minus I radical 7 over 4. God, that's an ugly answer. We can make it a little bit nicer when we realize that since they have common denominators of 4, I can just write the whole thing over 4 like this, and this will be my answer over 4. Boom, there it is. An ugly answer, but it works, all right? So why did I do this example? To show you we can get imaginary numbers and to show you how to deal with fractions because it gets ugly, all right? Text me with questions if you got them. Hope you're doing good.